thank you very much, and for also the invitation to speak here. And when I got the topic to speak in that session about secondary and critical raw material, I first have to say, what can I say? Actually, maybe at say some common conclusion on critical raw material, which are so diverse, and actually we don't even have a general definition on that. So maybe after all the presentations so now, which were very interesting, which had this more bird view on material flows, I want to take you a little bit more into a microscopic view. Maybe my background is actually, I come more from the traditional environmental engineering, have more a recycling and waste management background, and actually I think we can also learn from each other a few things. So in preparation, okay, I need to do it. In preparation of the of this speech here, of that day here, I somehow went back into the definition of critical raw material. And if we talk about the circular economy package addressing it, we may have the European focus, but there are also other definitions. I think the colleagues from Japan and the US have done several studies, and we see a few candidates which pop up in many of those discussions here. And if you look at them, I was thinking what makes them different maybe from aluminium or steel. And actually they are oftentimes impurities in the ores. And so also for the recycling, they are oftentimes nowadays, since we don't have a defined infrastructure to recycle them, there are actually impurities in the recycling systems. So, and subsequently lost. So what I want now to do a little bit is maybe to pick up, because they're so diverse, and but some of them are actually not used as alloys where we can say we can keep the material as it is in its functionality, but they are composites in very complex components where reuse makes sense, and but maybe recycling has a challenge of having to separate materials which are initially in primary production not really put together in the natural ores. So, and we just finished a German research project with a number of actors in the recycling chain, companies in the recycling chain, addressing the question, is it possible to actually, in the current system of recycling, to somehow get some back into the loop? And actually one thing of all the loop pictures we have seen so far, oftentimes when I try to map material flows and recycling systems, I'm not ending up with a loop, but with a network. And both in terms of production, it's a network, and in terms of recycling, it's a network. And maybe we need to understand the networks and the connections, and I want to try to do this in the next couple minutes. So maybe just to take a few examples, tantalum, actually have a very high, so electronics is one of the key end-use sectors of many of them, some of them, not all. And if we look at the actual usage, we find them in defined components in relatively high concentrations. So they are not so dissipated like they may be in nature, which includes a potential for bringing them back into the cycle. But if you look from a product level, they are actually oftentimes way below 1% in very low concentrations. So we'll talk a bit about gallium, tantalum, indium, and some of the rare earths. And maybe just to also keep it a bit short, I actually started to form some statements and conclusions that we ended up in that research project of, is it actually possible to get them back in the reloop, and what are the boundary or the limitations? And I think one thing has said already, we need to understand also waste management as one black box, but it's a relatively complex system. And we need to address also here the recycling chain or the recycling network. They're changing product design and long lifetimes of many CRM containing products require quite an adaptive technology. So it's not only about increasing stocks, it's also about decreasing stocks or shifting stocks. And some policy measures may set wrong incentives for recycling. And we have also, if we look at all these elements put together as conflicts in terms of recycling, that we cannot get all the material out, but we may sometimes make a decision: do we want the silver or do we want the tantalum? And we also, I will show an example on that, have historic products which contain material which actually nowadays we want to have excluded from the circular economy. And here just some results somehow we looked at. This is one example, batteries related to we. So we have one product included in another product, and looked at where we have a battery recycling infrastructure, we have a recycling infrastructure somewhere where to come together, and we looked at the flows of rare earth element and cobalt, and actually we see that for cobalt, nothing, or we have a recovered amount of cobalt from batteries that are incorporated in waste electronics, but due to lack of collection, we lose a lot in the beginning of the chain. If we look at the same situation for rare earths, we have the same loss in the collection, but later on in the end refining, there is still not, or there are technologies available, but they are currently not economic yet, so there is no rare earth ending up from battery recycling back into the loop. So somehow it really emphasized this looking at the recycling chain. Also, we talked about product changes, and we worked there together with a social company doing actually tantalum or dismantling tantalum capacitors, which have 45 to 50% tantalum, which are quite high grade, and are also, if you have them separated, they have a high market price, which is lucrative to companies. The dismantling itself, it's not so lucrative, but here social companies may play a role in that business model. But we looked somehow also at the trends of usage of tantalum capacitors, and what we see for many products is that they are more and more integrated. You have not the big parts identifiable sitting on the printed circuit boards. And if you look at then at products like tablet for computers or smartphones, which are very integrated, you actually don't find any of those components for recycling on them. So somehow we need also a long-term planning when these products will get back into the recycling system. Is infrastructure that might be now feasible then also still feasible? One other aspects, and we worked also with in some battery related project, that is this issue of changing products as well, and actually high material prices lead to substitution of the expensive materials. So the battery industry is actually aiming at cheap battery materials, and cheap battery materials mean oftentimes they are also less lucrative for recycling. And here you see the dominating battery type, which is nowadays in the recycling systems on the from you left-hand side, and on the other side the lithium ion, maybe the potentially battery systems of the future. But here you also see already a shift from cobalt rich or cobalt poor, and then with coming up new battery system that the difficult to recycle part is increasing up to 70%. And if we match that to recycling targets of 50% required recycling efficiency, it's somehow very difficult to match then with the recycling reality. The other thing that is maybe also setting the priority. So we can set, let's say, mass-based targets, which is oftentimes done. We also can set environmental targets or economic targets, and I think we have to bring those somehow together. And just to illustrate that there was numbers, so if we talk about ICT and consumer equipment put on the market, just in Germany, we talked about roughly 500,000 tons. And if you look at the critical raw material, actually we talk about tonnages which are sometimes for some materials like gallium below 1 ton in Germany. So you talk about really small amounts and that require a huge infrastructure and logistic if you want to aim to make it a political target to go at it. And if you go with the economic value, then you actually see that looking at the intrinsic value of a number of, for electronics relevant materials, it's quite dominated by gold. Actually, all the other elements and the related to the intrinsic based on nowadays market values. So it may take quite a while until economic drivers are here actually really in place, or maybe, and I think if we look at the ecology, we also see that oftentimes the energy intensive raw material like gold or precious metals are also determining the ecological impact. Maybe also to somehow close this part about the limitations, we looked at one product flow, the LCD panels, which actually have a high end use for indium around 70%, which are in the current status, there are requirements to separate them. And so there is a potential to get maybe the 200 ppm indium out of it, but we have a very high glass fraction, and our hypothesis was to make a business case out of it to have a purified glass fraction, and which can be reintegrated in the market. So we did some trials actually on separating, and since their main focus was then to get also the glass into a high quality recycling. The glass industry said, oh no, thank you. We don't want this glass because it's special glass with elements like strontium, antimony or arsenic. And since we then said, okay, LCD production is largely in Asia, but also the LCD production there changed recipes for their LCD recycling. So this is sometimes also, and maybe I will keep that a bit short. We tried somehow to get a drivers for CRM recovery. This is very strong focused on those, let's say, trace elements that make certain things very functional. So we had a product-related analysis, and a recycling chain analysis, and an economy-related analysis, and so somehow we came to a few points, and we may discuss that in the coffee break. But maybe just to get one thing, because one of the conclusions was somehow we need information more about the stocks that had been done before, but really also about the quality and the spatial distribution. And actually, if we go back to primary raw material, there is quite a bit of raw material intelligence. We know quite well how much stocks we have. Fortunately, those stocks, they don't move permanently or change permanently, but that led us into a Horizon 2020 research project where we try to map actually or prospect also secondary raw materials in line or in some analogy to the a primary raw material, and to create with consortium, actually an database from all the scattered information from research project, from traditional reporting on waste streams and so on, to process that into a sort of a database, an accessible urban mining knowledge data platform, which should be then also interoperable with the knowledge based on mineral resources. And I think we need to get those close to not see circular economy as a substitute of primary production, but somehow as a part of supply of raw materials. Okay.